Good morning, everyone. Welcome to our Autodesk Virtual Academy session for today. Like always, I'm Nigel Mbayak. Name hasn't changed in the last week or so. And today we have a great and exciting session for you guys on Inventor iMates. Jonathan Creek's going to be doing a presentation for you today. He is one of our manufacturing solutions engineers here on the KETIV team. Good morning, Jonathan.
Good morning.
For sure. So for those of you who are new, welcome to AVA. And for those of you returning, thanks for coming back every week. For those of you who don't really understand what AVA is, it's our once-a-week learning session that we do every Thursday at 10 a.m. for the manufacturing group of people. We do an AEC one as well. That is on every other Wednesday at noon. We do that. It's called AEC AVA. For those of you who are planning your next few sessions here to come and watch, the next one is Inventor AnyCAD and some other outside drawings, friend generator, and Inventor presentation. The really cool thing about this is all of these topics actually come from you, the viewers. We definitely take in all of your input at the end of the presentation or during for suggestions, and we implement those for upcoming AVAs. So if you definitely want to see something in particular, make sure you let us know, and we'll try our best to get that going as soon as possible. As usual, we will definitely cover questions during this presentation. Feel free to type a question in at any time during the session in the questions panel that is on your GoToWebinar panel there on the screen. Type it at any time. We'll definitely cover it either during the session or during the dedicated Q&A at the end. So without further ado, I'll go ahead and let Jonathan take over, and let's have a great session today.
Thanks, Nigel. So today we're talking about iMates, and as he mentioned, this is an actual a topic that one of our customers, or actually several of our customers, have asked about. So our agenda today is really to understand the purpose of iMates. A lot of you guys have seen it in Inventor, you've used it, don't really understand the intent behind it. So we're going to talk about where to use them, how to build them, and where they fit into your design. And so our topics are really iMates. We'll go and talk about exactly what are iMates, how to offer them, actually how to create them, and then inferring iMates. So there's the ability to create from existing constraints. Rather than just going into the model itself and actually creating it there, you can just derive it from some intelligence, some constraints you already have in your models. And then how do we go about actually using iMates once we've created them, actually assembling with them, and what's the overall purpose behind doing that? So what are iMates? iMates are a constraint pair. When we say constraint pair, so when you actually go in and constrain two parts, or you constrain a part to an assembly by proxy, there's a constraint pair that's created. And that may be a bolt that's inserting into a hole. There's a constraint pair there. Both parts of it, the feature and the part, have a relationship that's built. This tells the parts and subassemblies how they connect together. So you're at that point, with those constraints, you're defining the design intent as you're building it. And so when you create a single iMate, what you've established is one half of the constraint pair. I use this Lego example because it's very easy to understand, but Legos have built-in design intent with their pegs and with the holes. So if I'm creating an iMate for something like that, I'm building that intelligence into those pegs, and we know that they're just going to snap together, and we know that all the Legos, have some sort of design intent built in for that. So in Inventor, when we're talking about iMates, this comes, this term called Lego CAD. Autodesk didn't come up with the term Lego CAD. It's something that's been around for a very long time. But it's the method of snapping things together, making things a lot easier, predefining the design intent in the parts without having to go about, just defining it when you actually constrain components. So that's really the gist of what iMate is and what it's for. We're putting the design intent into it so that we can literally just snap things together. Now we're actually going to go into the demonstration, which is really the bulk of this. So what I have today is a pretty simplistic example. If you look at it, we have some table legs, we have some stone connecting between a top glass and a bottom glass, And this is a really good example to kind of show really everything in this can be put together using iMates. And not only that, but I can take some of these elements, define the intent, or design intent with the iMate to reuse it in a library for maybe another table design or maybe some other product that I'm working on. And so, if I'm building several different tables in this example, I don't want to have to constantly go in and constrain those components. If you look at Inventor's Content Center, this kind of idea of this predefined library that has bolts and things like that, they actually design iMate elements into a lot of those components. Obviously, bolts, the design intent is that it's going to be inserted into a hole or a extrusion or a void. There's other things that are going to be connected onto it. And, they went into bolted connections to make that easier, but the content library itself has iMates already built into it. And so you can generate your own parts in that manner. But let's look at just how to actually author an iMate and use it in its most simplistic, without defining the other half of the constraint set. So what I'm going to do is I'm going to actually open up this top glass panel, and you'll see that there's some extruded holes that don't go all the way through this part. We're kind of seeing it because it's clear, but the bottom portion, basically so that it can fit inside of this this peg right here and sit right on top of the stone leg or pillar, as we call it. So, I could come in and just make a couple constraints here. I could come in and say insert, this into this, and I would do that for all 4 holes. But I don't want to have to constantly do that. Really, this table by itself is really intended, it's cut for the specific table. The bottom glass has different size holes, it has a different hole pattern. So really, this is really intended to go one place. So anytime that I can use this glass and reuse it and snap it into the table without having to go and reconstrain it manually is going to save me time. That's one of the biggest things with iMates is you can snap things together, you can save yourself some time. And it's also, anytime that this is probably a simplistic example, I don't think that too many users would go about constraining this differently. Maybe they would use an insert or maybe align an axis rather than, put something on the holes, but it's pretty straightforward. But I want to make sure, that's what the purpose of iMates is, that everybody's doing it exactly the same. So if I can build in some design intent into this glass pane, then they don't have to worry about it. Essentially, they can drag and drop it or automatically apply those iMates, and we'll show you that. So how do I go about authoring this? So I go to my Manage tab at the very top, and I have this iMates button, or you can actually hit Q on your keyboard and get the same thing. So when I get the constraint iMates, it looks very similar to constraints, right? So I have a mate constraint, angle, I have tangent, I have insert. So I have really all the same abilities that I have with normal constraints. The only thing that's a little bit different is now I have this matching pane down here. And we'll talk about this after we kind of talk about how to author just basic iMates. So what I'm going to do is I'm going to put a insert, and I'm going to actually choose the aligned. And I'm just going to apply it to the feature, just like I was going to constrain it to another part. So this is the first half. That's what we said before. This is a half of the constraint set. So rather than doing this and then choosing an object, I'm going to place this intelligence into the model itself. So now you'll get this little iMate glyph. If you don't see the iMate glyph, there is a, usually when you right-click, it'll tell you that the visibility is turned off, or you can toggle that. So by default, you're going to see the iMate, but maybe you've already turned it off or something, so you can toggle that back on. I'm just going to do the same thing for all these other holes, because really it's going to have the same design intent. So I'm going to apply 4 iMates to this, this glass table. And you'll notice like when I choose angle and stuff like that, so it's just like your normal constraints where it's not going to allow me to apply certain types of constraints to the wrong features. So it's actually looking for a fit or a hole with this particular iMate. And so I'll save this part. I will actually close it, and I'll come back over and make sure that my glass top has my iMates. So when I selected it, now I see those 4 iMates in that part. And if I look at, this is the same thing you would actually see in the model itself too. If you look in your browser pane to the left, it'll actually show you, by default it actually names the iMate based on the constraint type it is. You can always change that name, and in fact we are going to change the name for matching iMates. That is actually doing both halves of the constraint set so that they'll just snap together automatically. But right now we're just doing one half of it, so it named it insert. That's what I see inside my assembly. And so how do we go about really just using these? So in a normal constraint, I would select the hole just like I did, and I would actually choose the the geometry I want to constrain it to. But since I have this iMate, the trick to this and the method you use is you actually select your component and hold Alt. And you see I'm actually still holding Alt now, and that iMate that I kind of selected is now highlighted. And I just drag it over to where I want to place, and you'll hear a snap. And so now that iMate is applied. And so what did it really do? It took just like you're in a normal constraint operation, I would choose, the hole, then I would choose the peg. So it actually just, as I dragged it to that location, it actually created the other half of the constraint set. So really all I've done is define, the first half of it, and now I'm able to, drag it. I can do the same thing with these others. Hold Alt down. Sometimes it's kind of tricky if you're looking at an angle. Make sure you're getting on the right surface. And essentially, it's locked down. I can't move it. But you can do the same thing with these other two. So I can hold Alt on top of it. It's not going to move anywhere, but it is going to snap, and it is going to actually apply that constraint. So now, inside of my part, it has actually applied those constraints. So we actually see the full constraint set using the iMate and just the geometry. So that's pretty cool. That's a quick way to go about doing it. But what's another way? Really, if I know that this is the geometry I'm going to select for this particular thing, like legs and maybe the post and other things, this might be the only method I use because I want to have more control over what geometry it's constrained to. But if I know exactly, the design intent is it's going to actually sit on top of these pegs, just like I've done, I can do what's called matching iMates. And so for that, I'm going to use the bottom glass. I'm going to open that up. And I'm going to do kind of the similar thing. The only difference here is that I'm going to create a set for this part, and then I'm going to go in and set another iMate set for the bottom peg itself. And so earlier we were talking about the matching set down here, and that's what this is used for. So I'm going to actually first just create my my actual constraint, my iMates, just like I did for these 4 holes on the top glass. I think I'm just going to use opposed for this. And I'm actually going to give it a name, and then I'm going to add a matching name to look for. So we'll call it leg base bottom. And it's important to just understand, that the naming is important because we're actually going to match that with another set. So I don't have to actually have that created yet. I'm kind of defining a definition to say when I insert this component, if you find another matching name with this name, then go ahead and apply a set. So I'm going to give it the same name. It's easier for me to name them the same. You don't necessarily have to, but you have to define the matching name exactly the same. So I'm going to name this leg base bottom, and the match is going to be leg base bottom as well. So I'm just going to quickly do that for all the holes. Even though I really don't have to, like once I have two corners, it's not going to be able to be moved, but it's a good practice to fully constrain things just like you would do with normal constraints. You want to do the same thing with iMates. And I'll just copy and paste that. And then all I'm doing is hitting add name to list, and then it's giving me the option to fill that out. So let's do that for the other. So essentially, I'm not saving really any time, setting this up, but I will save time when I actually go to apply that, or anybody takes this now part that I've added this stuff into. So I'm essentially doing the heavy lifting one time, and then everybody else can benefit from that. Okay, so I've done that. That's one half of the constraint set that's in there. I could drag and drop those things just like I did the other glass, but what I want to do is I want to go into my other side here, and this is going to be applied to the bottom glass. So I'm going to open this up. Oh, and here's where I actually had top and bottom. So, obviously, when you're applying an iMate to something like this, that really does have a true top and bottom. You don't want to, if I tell it to match to the top, that's where it's going to go. So I kind of put some planes in here to help me remember which is the top and the bottom. So on the bottom plane, don't think there's any iMates in this. Oh, actually there is. There is one for the top. So I'm going to add in a new one for the bottom. And here's where I actually make the match, or this is where the ability is to make the match. So I'm going to do the same type of constraint, and I'm going to give it the same name. I just copied and pasted, that into my clipboard history so I can add the same things here. And since this is one part, there's 4 instances of that inside the model. I only have to do this one time to match it with those holes. And you can always go in, this is something I didn't show, but if you ever make a mistake or you want to change, you realize you actually did the wrong direction or something like that, you can go in and just right-click and edit it, and you get your matching set. You can change the constraint type up here, so you can edit it just like normal constraints. That's all going to be in the browser. You can do that from the part or from the assembly level, but it is actually saved down into the part level. So I'll go ahead and close that, kind of update my model. I'll actually go into this in the browser and just make sure that I am seeing those iMates. So I do see my top on the top, and I do see the bottom on the bottom. So this component already has the iMates applied to it now. I'm actually going to just delete that out of my assembly and show you what a user would see, as they're completing their design. So now let's say that I need to insert that into my model. So I'll go to Place, go to my table, I'll choose my bottom glass, and here's where the options come in. So you have this iMates interactively place with iMates. So we'll do that first. So I'll check that option right before I hit open. I'm going to open now, and you'll notice that it automatically, saw one of the corners, and it said, hey, this is interactively placing. So all I need to do is click on the table on that iMate, and it's going to apply one. Now, the next set is going the wrong direction. So if I hit this, it's pretty much going to constrain it, going the wrong direction. So at the bottom, we have accept iMate result or select next. So I can actually right-click on it, and I have a bunch of different options now. It says place at all matching iMates, skip remaining iMate results, generate a list of those results, restart it, or just go to the next component iMate. So what I want to do is just go to the next one, and still not applying it, the way that I want it. I'll choose the next component iMate, and that looks like we're on the right track now. And so now I can go and apply it. All I'm doing is clicking those, and I'll just hit OK. So it didn't ask me for the third one, even though it's the same name. Sometimes that happens. So you can manually drag that constraint in. What works a lot better than this, this is more like if there's several different locations. So if you have a bigger table and maybe you name some of your iMates differently at the top, so it just gives you a little interactive way to go about it. What usually works better if you have something that's exact like this is to use the other option, automatically generate iMates on place, and we'll see how that works. And usually it just picks it in. It didn't do it this time. It's using the wrong constraint set. So there's ways to go about in fine-tuning that. Sometimes that is not just the design intent, but how you actually go about assembling those in your model. Sometimes you have to place your iMates in a certain order, manually select at least the anchor point for it to automatically apply the rest of the constraints. So sometimes those things happen, and you actually get those same type of results when you do when you're replacing constraints. How many times have you actually had to rotate a component just to get it to actually constrain in the right direction? So what's the other way of going about? So we did iMate matches. We actually created iMates inside the model from the very beginning. The other way to go about that is to actually infer iMates. And so for these bottom legs, we're missing some feet here. And I'm going to take on the notion of, it's to show you inferring iMates that that we don't already have an iMate in this. And we could go into that part, do just like we did with the table leg. We could actually just add an iMate, but maybe somebody's already taken this in their assembly. They've done C for constraint. They've actually did an insert constraint, chosen the base, and just inserted it into the leg. So I already have that done. Now I want to create iMates. Do I have to go back and add an iMate to the part, or can I just do it from here? So they have a method for inferring iMates. How you go about doing that is you take a foot, this foot, you actually select a constraint. This could be any constraint in your model, actually. Right-click the constraint and say infer iMates. So what that does is it's going to give you kind of this creation of the iMate dialog, and all you're going to really do is name it. If you don't name it, it'll create an iMate based on the type of constraint you use. So it'd be a, it would just say insert on the iMate. So I'll actually do that. I'll just say OK, and so it's now created an iMate there. So now, without having to go into the model, so it's actually done. If we actually open the foot up, it's actually created the iMate inside the model from the assembly, inferred from that assembly constraint. So that's a quick way to, create iMates inside of the parts themselves. So now when we go and place this foot, there's no matching iMates, but it already infers where I'm putting these things. So I can copy it and do the drag, or I can do lots of things with it. So selecting it, holding Alt down again, and dragging it to where it needs to go. So you could copy and paste that. The other thing, real quick, I know we're kind of running up against our time. I do want to get into the Q&A session, but the other things that you can do is if you already have a part inside of your model that has an iMate, but you didn't apply it, and you don't necessarily want to drag it, you can tell it to go back to that same menu that we were looking at to say, go ahead and automatically apply these iMates. So let's go back to our presentation and jump right into the Q&A session.
Perfect. Thanks, Jonathan, for that great demo. We do have a couple of questions in the queue. I have answered a couple of them, but we'll go over a few of them just so everyone hears the answers. So, for those of you who it's your first time here at the AVA sessions, a couple of people have asked where they could get our past webinars or if this one will be recorded and posted. And the answer to that is yes, we do record and post all of our webinars shortly after the live taping of them. You'll be able to find all of those on our YouTube channel. So if you go to YouTube and search KETIV Technologies, you'll be able to find that. And let's see, Michael Best. Hi, Michael, again for coming to today's AVA. And Michael asked, could you have held down the Control key and grabbed all 4 of the diameters when you applied the iMate? And I think this is for the top piece of glass, Jonathan.
Oh, so actually selecting, you know, all the iMates when I was actually interactively placing it? Is that the question?
Yeah, I think for that first one is when it came in.
Yeah. So let's take this glass piece and let's get rid of the iMates or the constraints there. So you're talking about as I'm holding Alt, selecting all of them. There's not a way to select, I don't think, because you're holding Alt down to get this movement. Control actually doesn't allow, you know, Control actually cancels it. But there is a way, you know, if you know that you want to take all of these and apply them, there's a menu when you're placing it to apply all iMates. So, but you don't really know, you know, in this case, I don't have a matching iMate with this geometry, so there's no way to know exactly what it's going to try to attach it to. So there's really not a way to do that in this mode, right? If I only have 1/2 of the constraint set, it's really looking for the geometry.
Mm-hmm.
And so in this case, it is just looking at one at a time, essentially, as I'm dragging it. We can look further into that. I hadn't actually tried doing that. I've always done the interactive placing. I do a lot of constraint sets or both iMates. But we can look further into that and see if there's a way to do that with only 1/2 of the constraint set.
Sounds good, and I'll touch base with you again, Jonathan, and make sure that we can relay that information to Michael. So Donnie has a question, and Donnie's working in Inventor 2014, and he'll be upgrading to 2016 shortly. Is there a difference between 2016 and 2017 in regards to iMates?
Not that I'm aware of, no. iMate functionality, the things that they've changed throughout the versions is they have made them in really constraints, right? So that the core of iMates is constraints. It's building constraint intelligence, so you don't have to actually build the constraint yourself, you know, as you're placing a model. The constraint system has been overhauled, it has been improved, and therefore iMate functionality has been more stable, I think, over the releases. So, but it hasn't, you haven't got new functionality or anything like that.
All right, sounds good. And then Andrew Johnson, he asked, do iFeatures yet have the ability to create iMates in parts?
So, no. There are ways you can build these, and that's something we didn't really show, but you know, you can take any of these parts with iMates, place them in libraries to become library components. You can certainly use iFeatures to create, you know, the holes and things and have iMates on those, but there's no interaction between the iFeature and the iMate.
Okay, and I think that's it for the questions. If you do still have some questions, oh, there's a couple more here. One just came in from Fred. Is there an iMate in every Content Center part? He hasn't seen it.
Yeah, there's not one in every single. A lot of those Content Center files were generated, you know, years ago. They added iMates into them. I know some of the newer ones have been updated. But again, you know, it's about design intent. So a lot of the parts, you know, they don't know exactly how you're going to apply them into your models, so they don't put iMates. And sometimes that confuses, you know, how to use those components. But things like bolts and washers, pegs, a lot of those type of things, there is, an insert iMate and things like that in it. We could actually probably at a later time show a little bit more about what's in the Content Center, because there's a lot of things in there other than iMates. There's actually some rules and some intelligence built into those parts too.
Definitely. And yeah, that's something that if you want to see more of, feel free to make note of that in the after session survey, and we'll make sure that if we get a lot of hits for a particular topic, we'll shoot that up the ladder and get that done sooner rather than later. And so I'm going to cover one more question right now, and that's from Octavio, and he's asking about iMates in iAssemblies. Is that possible, Creek?
Yeah, so you can have iMates in iParts and iAssemblies. Really, any type of component in Inventor, other than like the iFeatures, those are the actual components themselves. So library components, Content Center components, iAssemblies, iParts, they all work exactly the same way. And in some regards, you do have some access to change how those iMates, just like you have control over constraints, how they are manipulated. You can therefore manipulate the iMate. So maybe in your family table or something, you say, I want to suppress this entire feature or constraint, and maybe it flips it to the opposite direction. So there's some functionality there.
For sure. And there's a couple of more, but I think we're running out of time here. So I'll make sure to touch base with all these people who still have their questions in at a later time. Probably I'll touch base with you sometime today, so I'll make sure that gets done. Again, thank you for coming to today's AVA. If you want to stay connected, make sure you follow us on all of our social media outlets. It's not a way for us to get more followers. It's we like to think of it as a way for you to be able to get connected to us. Whether or not you have questions, suggestions, or even just want to have chat about what you guys are doing in your business, definitely shoot us a message on Twitter, Facebook, or even shoot us emails. That's not a problem. And again, like I said at the beginning, our next week's session is Inventor AnyCAD, and then some other outside Autodesk files and how to bring those in into your workflow. Make sure that you're working well with people, say, for example, vendors using SolidWorks and whatnot. We'll definitely cover that next week. We've got a great presentation coming for you. So with that, I'd like to thank you, Jonathan, again, for doing this presentation for us today.
You're welcome.
And I'd like to thank you all for coming here today. Have a great weekend, everyone.
Have a good week, guys.